Hello and welcome back. This is day 2 of solving exponential functions. Question number 1, it says to rewrite the following numbers so that they have the same base. So looking at number 1, we have 5, 125, 3,125. If we look up here at the table of powers, we can find the number 125 here and also 3125. All of those are in the same row with 5 as the base. So what that means is that 5 raised to the third power is 125, and also 5 raised to the fifth power is 3125. So putting that all together, we can rewrite 5, of course, as 5 to the first. 125 is 5 to the third, as we saw in the table. And we also saw that 3125 was 5 to the fifth. Question number 2. Again, we're going to write both of these numbers, 729 and 6561, using the same base. So let's go up here and see if we can find both of these numbers in the same row. Well, you'll notice that 729 and 6561 is in the same row with 9 as the base. So 9 to the third power is 729, and also 9 to the fourth power is 6561. So that's exactly how we will write these numbers. That's 5 to the third power, 9 to the third power. 9 to the third power is 729. And 9 to the fourth power is 6561. All right, now for the examples, we're about to solve these exponential equations. But let's look at the 3 steps for solving. Steps for solving a simple exponential equation, and that is when x is in the exponent. Step 1, you want to isolate all the powers on the opposite sides of the equal sign if necessary. Step 2, rewrite equations so that each power has the same base if necessary. And then step 3, we want to set exponents equal to each other and solve for x if necessary. If there is only one power, use the exponent table to determine the value of the exponent and solve for x. All right, so let's start with number 1. We have 5 raised to the x plus 7 is equal to 8. So we want to isolate 5 to the x by itself on the left side. So let's subtract 7 from both sides. And we'll get 5 raised to the x equals 1. Now we want to write both sides using the same base. And it just so happens that 1 can be written as 5 raised to the power of 0. Well, we all know that any number raised to the power of 0 is 1. So in this case, we can say that 1 is equal to 5 raised to the power of 0. So now we have 5 raised to the x equals 5 raised to the 0. And now, since they have the same base on both sides, we can drop the bases out and set the exponents equal to each other. That simply means that x must be equal to 0. And that is our solution. All right, for number 2, we have 9 raised to the 2x equals 3 to the 2x plus 4. The idea would be to write both sides so that they have the same base. And we can actually do that, because 9 can be written as 3 to the second power. So let's rewrite it that way. We're writing 9 as 3 to the second. So that's 3 to the second raised to the 2x equals 3 to the 2x plus 4. Well, now we use properties of exponents where the 2 and the 2x, they get multiplied together. So now we can write that as 3 to the 2 times 2x, which is 4x. So 3 to the 4x equals 3 to the 2x plus 4. Since we have the same base on both sides, that means the two exponents must be equal to each other. That means the exponent of 4x must be equal to the exponent 2x plus 4. So let's set those equal to each other, and then it's just solving for x. So we'll subtract 2x from both sides. We get 2x equals 4, and then let's divide by 2 on both sides, and we have x equals 2. All right, for question 3, we have 1/2 times 10 raised to this power minus 7 equals 49,993. Well, what we want to do is we're trying to get this 10 raised to that power by itself. So first, let's add 7 to both sides. And that's going to give us 50,000 on the right. Now let's undo the multiplication of 1/2 by multiplying by 2 on both sides. And multiplying 50,000 times 2 is going to give us 100,000. And now the trick is, can we write 100,000 using 10 as a base? In other words, is it true that 10 raised to some power is equal to 100,000? Well, yes, because you know every time you multiply by 10, you just add another 0. So this is a 1 with 5 zeros, and that means that 100,000 must be equal to 10 raised to the 5th power. Well, now we have the same base on both sides, base of 10. So at that point, we can drop those bases and set the exponents equal to each other. So 2x minus 3 must equal 5. And then we just solve for x. So let's add 3 to both sides. And we get 2x equals 8. And then let's divide by 2. And we get our final answer, x is equal to 4. All right, here's question 4. We have 4 raised to this power plus 2 is equal to 2. Well, we want to try to isolate the 4 raised to the power by itself. So let's subtract 2 on both sides. So now we have 4 raised to some power is equal to 0. Well, if you stop and think about this, this is actually impossible. 4 raised to any power will never be 0. So there's actually no solution. All right, for question 5, we have e raised to some power equals 1 over e raised to some power. Now the trick to this is to rewrite 1 over e as e raised to the negative 1. Right? Once again, 1 over e is the same thing as e raised to the negative 1. And now we're able to write both sides using a power of e. All right, the next step would be to distribute the negative 1 times the 3x minus 8. And that gives us negative 3x plus 8. So now we have the base of e on both sides. And now we can simply set the exponents equal to each other. That means that 2x minus 9 must be equal to negative 3x plus 8. Let's go ahead and add 3x to both sides. And then let's add 9 to both sides. So now we have 5x equals 17. And now we can divide by 5. So x is going to be 17/5. Okay, so on the left side we have a base of 8. On the right side we have a base of 1/2. I believe we can write both of those bases as a common base. And I think that base is going to be 2. We can rewrite 8 as 2 to the 3rd power. We can also write 1/2 as 2 to the negative 1. So the common base is 2. So we have 2 to the 3rd raised to the x minus 1, and then 2 to the negative 1 raised to the 2x minus 1. Let's go ahead and distribute the exponents. So 3 times x minus 1 is going to be 3x minus 3, and then negative 1 times 2x minus 1 is negative 2x plus 1. And again, we have the same base of 2, so we can drop the bases out and set the exponents equal to each other. That's going to give us 3x minus 3 equals negative 2x plus 1. Well, let's go ahead and add 2x to both sides. And then let's add 3 to both sides. And then let's divide by 5. And we get our final answer. X is 4/5. All right, that concludes the lesson on solving exponential equations.